Visit Chandra's beautiful universe. RAX J0320-35. Astronomers have discovered a black hole that is growing at one of the fastest rates ever recorded. This discovery from NASA's Chandra X-ray Observatory may help explain how some black holes can reach enormous masses relatively quickly after the Big Bang. The black hole weighs about 1 billion times the mass of the Sun and is located about 12.8 billion light-years from Earth, meaning that astronomers are seeing it only 920 million years after the universe began. It is producing more X-rays than any other black hole seen in the first billion years of the universe. The black hole is powering what scientists call a quasar, an extremely bright object that outshines entire galaxies. The power source of this glowing monster is large amounts of matter funneling around and entering the black hole. While the same team discovered it 2 years ago, it took observations from Chandra in 2023 to discover what sets this quasar, RAX J0320-35, apart. The X-ray data reveal that this black hole appears to be growing at a rate that exceeds the normal limit for these objects. When matter is pulled toward a black hole, it is heated and produces X-rays and optical light. This radiation creates pressure by pushing out on the matter, which counteracts the force of gravity pulling the matter in toward the black hole. When the amount of matter becomes large enough, the pressure from the radiation overpowers the force of gravity, giving a limit on how quickly matter can typically fall toward a black hole, called the Eddington rate. Scientists think that black holes growing more slowly than the Eddington rate need to be born with masses of about 10,000 suns or more, so they can reach 1 billion solar masses within 1 billion years after the Big Bang, like they have observed in RAX J0320-35. A black hole with such a high birth mass could directly result from an exotic process: the collapse of a huge cloud of dense gas containing unusually low amounts of elements heavier than helium, conditions that may be extremely rare. If RAX J0320-35 is indeed growing at a high rate, estimated at 2.4 times the Eddington limit, and has done so for a sustained amount of time, its black hole could have started out in a more conventional way, with a mass less than 100 suns, caused by the implosion of a massive star. By knowing the mass of the black hole and working out how quickly it's growing, the researchers were able to work backwards to estimate how massive it could have been at birth. With this calculation, astronomers can test different ideas about how black holes are born. This result has implications for how some of the universe's first generation of black holes formed, which remains one of the biggest questions in astrophysics.